Hello friends, in this video we will be discussing about the simulator for microprocessor 8085. So we will see one simulator. So that simulator is called GNUSim8085. So this particular simulator we will be using, okay? And this simulator will be used to simulate our microprocessor 8085. Okay, so simulating means that we will use this particular simulator to simulate all the programs that can be run on microprocessor 8085. And what is the use of simulator? Why will require a simulator? So if we don't use a simulator, we have to buy the actual microprocessor and then run our code on that microprocessor. And our simulators make it easy that instead of buying an actual hardware, we will buy a software for that particular device and use that software to run all the programs that can be run on microprocessor 8085. And this video will help you in understanding this particular simulator. Okay, so let's start the same. The first thing that we are going to do is to download this particular simulator. Okay, this GNU Sim 8085. We will first download this particular simulator and then we will see how we can use this simulator. So for downloading this simulator, go to this particular website, GNUSim8085.github.io. Okay, now let's go to this particular website. From here, go to all downloads, and from all downloads you can download the installer for your operating system. Okay, so since I'm using Windows operating system, so I will download this .exe file. However, if you are using some other system, for example, some Linux system, then you can download the package for that particular system. Okay, so our simulator has been downloaded. So let's install this particular simulator. Fine. So we have to install this simulator. Okay, it will take a minute to get installed. So here our simulator has installed itself. So let's finish and our GNU Sim 8085 will start. Okay, so this is our simulator. Okay, or we can say this is the complete interface of this particular simulator that we will be using to simulate microprocessor 8085. So before writing the programs and giving you the idea how to execute those programs, first thing that we are going to do is to see the different components that are there in this simulator. Okay, so let's start from here. So this particular section will be used to write your programs. Okay, so we will write our programs in the assembly language of microprocessor 8085 in this particular area. Okay, this area will be for writing the programs. Fine. Now after that, if you see that there are some other sections here, for example, let's take this particular section. Okay, so we know our microprocessor 8085. Let's take this particular section. Our microprocessor 8085 has registers. So it has 6 general purpose registers, the registers that we call BC, DE, and HL. Okay, and all these registers are 8-bit registers. Fine. So we have 8-bit registers, and we know how many such 8-bit registers are there. There are 6 8-bit registers. So these are our 6 8-bit registers. Okay, and here BC means that this particular 2 hexadecimal digits will represent the data contained in register B, and these 2 will represent the data contained in register C. Likewise, these 2 will represent D and E, and these 2 will represent H and L. And there is a special type of register which we call the accumulator, and this accumulator is also of 8 bits, so it is represented using these 2 hexadecimal digits. Okay, So apart from registers, we know that there are other special purpose registers in microprocessor 8085. So one such register is program counter. And we know program counter is of how many bits? It is of 16 bits. Okay, so 16 bits, that is why we have 4 hexadecimal digits here. Likewise, stack pointer, for stack pointer, we have 16-bit stack pointer. So these 4 hexadecimal digits will represent a stack pointer. Apart from this, there are 2 registers also, for example, program status word and this integer register. So we won't be discussing about these 2 registers here. When the time will come, we will discuss about these 2 registers as well. Okay, so this was about the registers that are there in microprocessor 8085, and our simulator is giving us these 3 registers here. Okay, so anytime you can view this register and see what is the value contained in this particular register. Fine. Now, apart from registers, we know that our microprocessor 8085 has flags as well. So these are the 5 flags that are there in microprocessor 8085. And we know what are the 5 flags: sign flag, zero flag, auxiliary carry flag, P flag, and carry flag. P is the parity flag. Okay. And each flag is a 1-bit entity. So here, this value will be either 0 or 1. And initially all the values are reset. Reset means all the values are 0. Okay, so we have completed this portion. Now this simulator provides one functionality here. So using this functionality, it will help us to convert any decimal number to hexadecimal or any hexadecimal number to decimal number. For example, if I take a hexadecimal number, if I take a decimal number, for example, 15, and we know 15 in decimal is represented in hexadecimal as F. So if I convert, it is F. Likewise, if I give a hexadecimal number A, and we know A in decimal is 10, so I can convert it to decimal and this will be 10. So this particular box will be used to convert hexadecimal to decimal. Fine. So apart from this box, there is another box here. This one. Okay. So the use of this box is that it can be used to change the value of any input output port. For example, if there is an input port, okay, so I have to give the address of that input port here. And if I have to write some data at that input port, for example, if I am saying that there is input port 1, okay, and the address of this input port is, for example, let's say 02 in hexadecimal. So here in this simulator, all input output ports will be addressed using 8 bits. Okay, so every input output port has 8-bit address. So if I have to say that at this input port, I have some data, for example, data is 5. Okay, then what I am going to do, I will write the address at this particular location, that is 02, and the value that I want at that input port, that is 5, I will write that value here. Okay, and if I check the input port after updating the port value, the value at this particular port will be 5. I will demonstrate this, but in a minute. Okay, so this is about this particular part. Now there is another section here, memory. So for example, you want to write some value at some location in the memory. Let's say there is a location 1000 in hexadecimal. Okay, so this is the memory address, and you want to write some value, let's say 23 in hexadecimal at that particular point. So what you are going to do, write the memory address here and the value here and update memory. Okay, let's give here the address of the memory. Basically, the address that we are going to give here, this will be the address in our decimal format, not in hexadecimal format. So let's write an address, for example, any address 120. And let's say I want to update the memory at address 128 as 23. Okay, so let's now go to that particular memory location. What is the memory location? 120. And you can see here that 120 has 23 stored. Okay, so this is the data. So this particular window or this particular tab, memory tab, this shows us the status of the memory, what is stored in our memory. So whatever is there in the memory, it will be shown in this particular tab. Likewise, another thing that we have here, another tab, that is the input output port. So this input output port says what are the input output ports and what is the address of each port. For example, address, the port with address 0, it contains data 0. The port with address 5, it contains data 0. Fine. Okay. Now, for example, you want to say that there is some port and the value at that port is 5. Okay. Let's take this particular port 7, port with address 7. Let's say you want to update this port. So you can go to this input output port and write an address and write the value what you want to store. Let's say I want to store 10 in hexadecimal. Okay. And I will update. Let's go to 7. So what is stored here? 16. However, what we stored 10 in hexadecimal. 10 in hexadecimal is equal to 16 in decimal. Okay. That is why here we have data 16, because the data that it shows, it is in decimal, not in hexadecimal. Fine. And whenever you have to update a value here, you are updating in terms of hexadecimal, not as a decimal. Fine. So we have completed memory and input output ports. So there are other tabs here. For example, stack is here. So we know that stack is a portion of memory in which we push some data and we pop some data from the stack. So basically stack is a memory. Okay. And here also it is a memory, but initially we know that there is nothing on the stack. So this stack is empty. However, when we are going to do the programs in our microprocessor 8085, where we will be using stacks, we will see that our stack will get filled by after executing our program. Okay. And there is another tab called data. So we are not going to discuss about this here. And here we have keypad. Okay. This tab is basically, it contains the different instructions that are available here for microprocessor 8085, and it is just an index of instructions. Okay. So you can take help from this keypad tab to find various instructions that are available. So this is our memory. Okay. Now, since we have updated this memory, for example, at one location, we have at this location, 120 location, we have value 23. Likewise, input output ports at location 7, we have updated 16. So let's refresh everything. For example, let's start from the beginning. So in the beginning, we know that all the IO ports, the data is 0, and for all memory locations, data is 0. So we have to reset memory and input output ports. And how we can do that? We can go to this reset button, and from the reset button, you can reset, for example, memory, and then you can reset IO ports. So now there is nothing stored in IO ports. For example, at 7, previously it was 16, now it is 0. Likewise, memory has been reset. So this was all about our microprocessor simulator, which is called the GNUSim8085, and you all download this particular simulator and start working. Okay. So I will upload some more videos regarding this particular simulator, and we will see in those simulators how we can write programs in this particular simulator and how we can execute those programs.